section 14.8 talks about Lagrange multiplier. Lagrange multipliers are dependent on excuse me, a constraint. So suppose we have two functions f of x, yz and g of x, yz that are differentiable, and the gradient of g does not equal 0 when g equals 0. The extreme values, the minimum or the maximum values of f of x, subject to the constraint. So unlike the previous section you could find a maximum or a minimum to any function. You don't need a constraint. Lagrange multiplier works only on constrained or restricted regions. Can be found by solving the system of equations. You take the gradient of f, the gradient of UG, and multiply g by lambda, and g of x, y, z, the constraint to make a system of equations, and solve for those. Basically what you really want is x, y, and z, but lambda would be the key for doing that. So Lagrange doesn't really work with finding f sub x equals 0, f sub y equals 0, f sub x, f sub saves all of that time, provided there's a constraint, provided it's restricted. So here's an example. Find the extreme values of the following functions subject to the given constraints. A, this is the first one. What you do, you find the gradient of f, that is 2x, that's 2 and 3. It's simple because that's linear. You find the gradient. Now g, you'll notice really quickly, whether you write it this way or this way, it's not going to matter. The gradient, and that is g though. The gradient of g is going to be 2x, 2y. So if you take the gradient of f equals lambda times 2x, 2y, and x squared plus y squared equal 9, and solve. So what I'll do, I'll solve for an x or a y in there. This says 2 equal 2 lambda times 2x. And this says 3 equal 2 lambda y. So if I solve for lambda, lambda equal 1 over x, I could solve for this so many ways, and lambda equal 3 over 2y. Since lambda is the same, that means 1 over x equals 3 over 2y. This is still solving only using the first equation. I haven't used the bottom equation yet. And if I cross multiply, 2y equal 3x, or y equal 3x divided by 2, take this now and substitute it in this, and you can solve for x. X squared plus 3x over 2 squared equal 9. Once I solve for x, plug it in and find y, and I'm done. So basically, it's nothing more than a system of equations. That would be what? 13 over 4x squared equal 9. So x squared equals 36 over 13. And x will equal plus or minus 6 over radical 13. If x equals 6 over radical 13, y would be 3 halves times that. 2 divides, so if you take 6 over radical 13 and multiply that by 3 halves, 2 divides 6 3 times, that's 9 over radical 13. And when you have x equal negative 6 over radical 13, y would be a negative 9 over radical 13. The way you wouldn't put a plus or minus. If you say plus or minus a, plus or minus b, this is 4 cases. This is only 2. Either they're both positive or they're both negative. And that makes sense because it's a circle and this is a plane. but these are the points that you need. Now there's the other catch. It doesn't tell you whether it's a maximum or a minimum. You just find what they are. Now you could plug them in. You could figure out f of the first, f of the second. Of course, the higher is a maximum and the lower is a minimum. But if I only got one value and I plugged it in, it doesn't tell you whether it's a maximum or a minimum. They find the extreme values, the local extrema, but they don't specify what it is. When a problem says find the maximum, they say, oh look, that's the maximum. When you look for the minimum, they say, oh look, that's the minimum. But it does solve problems very fast and very efficiently. So, if I want to use Lagrange multiplier to solve this, I'll take the gradient of f. I should have used colors on the first one. That would have made life easier. I'll find the gradient of g. Remember, it's not going to make much of a difference from most of what we do. The gradient of g, and this is g, that would be 1, 2. So I'm going to take the gradient of f and set it equal to lambda times the gradient of g. That means I'm going to take lambda times 1, 2 and yx. So that means y equals lambda and x equal 2 lambda. The way this works, you could solve for lambda and it'll make your life easier. And now take this and substitute it right there. That indicates that y equal x over 2 or x equal 2y. It doesn't matter. Now, this is the first case. And the constraint. The constraint is x plus 2y equal 5. But if x is 2y, that means 2y plus 2y equal a 5. So I'm using substitution. That means y equal 5/4. And if y equal 5/4, x is 2 times that. That makes it 5 halves. And there it is. One extreme value for this. And the extreme value, if you really want to find it, it will be f of 5/4, 5 halves, which is 25/8. Another problem. I'm going to take the system of equations. I'm going to take the gradient of f, which is with respect to x, y e to the x. With respect to y, e to the x. And I'm going to set it equal to lambda times the gradient of, if you move the 4, that's not going to affect the gradient, that's 2x, 2y. Along with x squared plus y squared equal 4. Those two. I'm going to take the top equation and say y e to the x must equal 2 lambda x and e to the x equal 2 lambda y. And the way it works, again, if you solve for lambda, you save yourself a lot of pain. Just make it a habit. Of course, there are shortcuts you could find. And since lambda is the same, then you eliminate lambda out of the equation. And now you're dealing with a system of just x and y. Y e to the x over 2x equal e to the x over 2y. The exponentials cancel out. Cross multiply. 2y squared equal 2x, or x equal y squared. Let's keep it at that. Take this now and put it right there. That would mean y squared squared plus y squared equal a 4. That would mean y to the 4th plus y squared minus 4 equal to 0. And that would mean, can I factor that? Let me think really quick. Minus 2, that doesn't work. That means y to the 4th plus y squared take half of the middle number, which is 1/2, and square it. You could use quadratic formula, of course. That means y squared plus 1/2 squared equals 9/4. That would mean y squared plus 1/2 equal plus or minus 3/2. And y squared would be negative 1/2 plus or minus 3/2. So y squared would equal negative 1 plus 3 is 2 over 2, which is 1, or y squared equal a negative 2, which is not possible. So y equal plus or minus 1. If y equal plus or minus 1, x will equal 1. There it is. Those are the two values. The actual extreme value is f of 1, 1, which is e, and f of 1, negative 1, which is x equal 1, y equal negative e. So obviously that's a maximum and that's a minimum. And I just want to tackle one more problem. We did that in the previous section. I'm going to show how that works. So find 3 positive numbers whose sum, that's a restriction, whose sum, x plus y plus z, is 8. Find 3 positive numbers and whose squares, and the sum of whose squares is as small as possible. So I'm trying to find the sum subject to this constraint. That's constraint. Of course, you can subtract 8 from both sides. It's not going to matter. So how does it work? If I call this f, and I apply the same analogy, the gradient of f is 2x, 2y, 2z equals lambda times the gradient of g. The gradient of g is 1, 1, 1. So, and don't forget, and x plus y plus z equal 8. If I take the top piece and play with it, I have 2x equal lambda, 2y equal lambda, and 2z equal lambda. Since those are equal, that means 2x equal 2y equal 2z, or x equal y equal z. If I plug those here, wouldn't that be x plus x plus x equal 8, 3x equal 8, which means x equal 8/3. And what does that mean? They're all equal. Y equal 8/3 and z equal 8/3. So 8/3, 8/3, and 8/3 would be the solution. It's very efficient and quick to find a maximum or a minimum using Laplace than it is the traditional method. And that would be it for this section.